Number 18 on the 12B. Okay, so we have someone playing a game repeatedly with the probability of winning of 1/3. The outcomes of the games are independent. What is the expected number of games till he will play until he will both won and lost at least once? That's interesting. There's two ways to go about this. I'm going to show you the really quick, simple solution, which can really be done in like 30 seconds if you do it carefully. Okay, so probability of winning 1/3. How many games till won and lost both once? First thing to consider is the first game, because this will set the tone for the rest of the whatever, how many games are played. So let's say the first game is a win. First win. The probability of this is 1/3. Okay, let's say first one was a loss. The probability of that is 2/3. So let's say the first one was a win, right? Let's go back to this. Now we already have the win. We already have the first. We have the one, the game that AMC won, and now we have to have a game that lost. So what's the expected number of games till a loss comes? Well, the probability of losing is 2/3, right? Let's say we have a win. Like this was a win. This was a L, right? So let's say this was another win, right? That's not helping us because now we have to have a game we have to have one W and one L. So now we know this first one is a W in this case. And then now we have some sequence of moves later, until we get our first L in this sequence. And the probability of losing is 2/3. So basically okay, we have one game here. How many games are expected to be here until we get our first loss, right? Because we already got our win. And how do we do that? Well, there's a really neat property in expected value. Well, let's say the probability of rolling let's just take a simpler problem. What is the expected number of times you have to roll a dice to get a 6? The probability of rolling a 6, 1/6. The expected value, as you might imagine, is just 6, right? Because it takes an average of 6 times to roll a 6 because you can think of it like the probability is 1/6. The expected value is 1 over the probability. So let's say we're flipping a coin. What's the expected number of times to get a head? That's 2. Maybe something has an event of 1/3. The expected number is 3. And this applies even for other probabilities. Let's say the probability is 2/5. The expected number is just 2.5, 5 halves. So this thing always applies. If the probability of something is P, the expected number of moves till we get that is 1 over P. So with that mindset, let's see if we can calculate the expected number of moves needed. What's the expected number of moves here needed to get an L? Well, the probability is 2/3, so the expected number of moves is just 1 over that, 3 halves. Right? So there's 3 halves on average moves here. Because as you can imagine, that makes sense, right? Chances are we're just going to get it in our first try. Because there's a 2/3 chance it happens. Maybe we'll get it in 1 or 2 tries, maybe more. But on average, it's going to be very close to 1. Because it has such a high chance of happening, 2/3. So in this case, the expected number of moves is total 5 halves. Let's not forget this one win over here. Right? So 5 halves. Okay, this case is very similar. It's the same logic, essentially. How many expected moves here? Well, what's the expected number of moves till we get a W? There's a 1/3 chance of getting a W from here. So the expected number of moves is 1 over 1/3, right? So on average, it's going to take us 3 moves to get our first win. So the total number of expected moves here is 4, because 3 is the expected number of moves after our loss, and then 1 is, of course, the number of games for the first loss itself. So on average, we have 4 games played if our first game is a loss to achieve this goal of winning and losing at least once. So now we just add up these cases, right? The probability, in this case, we have an expected value. In this case, we have an expected value. We add it up to get the total expected value. That's 5/6 plus 8/3, or let's just say 16/6. And that is 21/6 or 7 halves. And that's the final answer. So yeah, I think this problem is fairly straightforward. All you have to do is consider the cases where you win and lose first, and then say, expected number of moves after that using our handy, probability P, expected number of moves to get that is 1 over P. And that's it for this video. I hope you enjoyed.